In today's session, we'll be discussing about another networking important topic, that is transmission media. How the signals are transferred from one node to another. Today we'll be discussing about guided media. What is transmission media? The transmission media refers to the technical devices which employs the material substance to transmit or guide the waves. It is a physical pathway that connects computers and transfer the connections. There are two types of media basically, that is guided media and unguided media. Guided media consists of twisted pair, coaxial cable and fiber optic cables, and unguided media includes microwave and infrared rays. Today we are going to discuss in detail about the guided media, its types, the bandwidths, and the propagation methods which they use. First, we'll be discussing about the types of cables. There are coaxial cables and the twisted pair cables. And the base which is used to make those cables are copper medium because it is the cheapest mode of data transfer. A pair of cables twisted around each other, as the name suggests, is a twisted pair cable. Twisted pair cable has two types, unshielded and shielded twisted pair cables, UTP and STP. It is least expensive, very easy to install, flexible, and they're very widely used. The two types there are there, unshielded twisted pair and shielded twisted pairs. UTP is more less expensive as compared to STP. It is the least expensive, it is light and flexible, it is easy to install, it is not shielded by any external conductors, so that makes it prone to the electromagnetic interference and the noise, though twisting somehow still minimizes the electromagnetic interference. See, this is an example of a twisted pair cable. This is mainly used in the LAN environments. It's very easy to install, but gets affected by the magnetic and radio wave radiations. Normal cable length is around 100 meters and bandwidth is 100 Mbps, and the connector which is used popularly is RJ45 connector, and you can easily bend these cables almost to 360 degrees, that won't make a difference, and resistance is of 50 ohms, and the signal based. There are different categories of UTP cables. For example, we call them as Cat 1, Cat 2, Cat 3, Cat 4, Cat 5, Cat 5e, Cat 6, Cat 7. These are the categories. Basically, the Cat name is from the number of twists in the cable per region. The more the twists, the category increases. Here it is indicated that Cat 1 is normally used for telephone cable and category 2 provides for 4 Mbps. Generally, nowadays we have Cat 5 and Cat 6. Cat 5 is 100 Mbps and we are going towards Cat 6 1000 Mbps. And Cat 6A, 7 and 7 are mostly for trial and research purposes. So the twisted pair of copper wires is surrounded with this metallic braid or the sheathing. So because of this sheathing sheet, the interference is reduced. At lower data rates, STP provides better performance than the UTP, and it is more susceptible to the electrical noise, though it is little more expensive as compared to the UTP. It is bulky, less flexible, installation is more expensive as compared to the UTP. Types of STP cables are a Cat 5e, which provides speed up to 1000 Mbps and has resistance of 150 ohms. Advantages: they are easy to terminate, cost of installation is less, high installed base, and it is very noisy, it covers less distance, and it suffers from interference. Comparison of UTP and STP cables. For UTP, data range is 10 to 100. For STP, it is 150. Cable length is 100 meters for UTP and STP 500. Electrical interference, it is more, UTP is more susceptible as compared to the STP. Installation is easy to install in both the cases. And cost-wise, price-wise, UTP is less expensive than STP. The outer core provides a shield. So makes it highly resistant to the electromagnetic interferences. It is less susceptible to the crosstalk as compared to the twisted pair cable. It can support greater cable length between the network devices. It supports larger bandwidths and it is also bulkier. It is more difficult to install than the twisted pair cables and it is more expensive than the twisted pair cables. Coaxial cables are normally used in Ethernet, thick Ethernet, and is replaced by category 5 UTP cables. They have the solid copper core which is surrounded by an insulator material which is mainly made of PVC or Teflon, which makes it more susceptible to the electromagnetic interferences. This was invented by Oliver Heaviside in 1880. Coaxial cables are mostly used in the broadband systems and provide greater bandwidth with lower error rates. They are useful both in analog and digital data transmission. They have higher installation cost, number of connection nodes is limited, and it is susceptible from the lightning. Next, we have fiber optic cables. A fiber optic cable is a thin, flexible medium capable of conducting light. It has the ability to transmit signals over much longer distances as compared to coaxial as well as twisted pair cables, and they provide very high data rates. Approximately up to 50 Gbps speed is possible if we use fiber optic cables. Nowadays, most of the high-speed broadband connections are using fiber optic cables only. And moreover, because they are susceptible to electromagnetic noise and interference, optical fiber has the advantage of being thinner and lighter as well as compared to coaxial or twisted pair cables. It has lower attenuation rate when compared to coax or twisted pair cables. Since it uses light as a transmission medium, the problem of electromagnetic interference is totally eliminated. It is also immune to the environmental disturbances like moisturing or lightning. In the upcoming future, the demand of fiber optic cable is growing to increase exponentially because the demand for the higher bandwidth is going to create more pressure. As moreover, it is a highly secure medium, it's very difficult to break into and crack the code. It's almost like as if you're using a firewall into your network. But the major disadvantage of fiber optic cable is it is very expensive and you need an expert person to do the installation, which is again adding on to your cost only. Another problem is they are very thin and very delicate to work with. You cannot bend the fiber optic cables as the transmission medium is light. If you will bend the cables, your signal will not be transferred, it will be lost. So the main characteristics, the bandwidth range starts from 100 Mbps to 1 Gbps and transmits signals over from 2 to 100 kilometers. And interferences, no electric signals pass through these types of cables, thus provide the high security. Fiber optic cable has further three types: plastic core and cladding, glass core with plastic cladding, glass core with glass cladding. Cost varies in all these three categories. Obviously, glass core with glass cladding is the most expensive and most difficult to install. The advantages of fiber optic cables, as you can see, really outnumber the coaxial and the twisted pair cables. They have wide bandwidth, low losses, immune to crosstalk, interference to immune, very lightweight, small size, long-term benefits. It provides more strength and security, best suited for the long distance transmissions. Environment to they provide immunity to any environmental disturbances, safe and very easy to install. But they provide very high initial cost and the maintenance cost and cost of repairing is also very high. This was all about the guided media. Please like and subscribe my channel. Thanks for watching.